Welcome to the mathematics class. This class is for class 9 in continuation to the previous class of midpoint theorem. In the previous class we were discussing exercise 11 and we have done up to question number 6. Now we will start with question number 7. What is question number 7? I will read it out. It is given in the adjoining figure, means the diagram is given to us. In the diagram you can see there is a triangle ABD. They say AD and BE are the medians of triangle ABC. So AD and BE are the medians. If AD is the median, it means that BD and DC are equal. And BE, if BE is the median, it means that AE and EC are equal. This is the meaning of the medians. Second point that is given is DF is parallel to BE. DF, this line DF is parallel to BE. These two lines are parallel. We have to prove that CF is equal to 1 upon 4 of AC. CF, this small part, is 1/4 of this total side. So what we'll do in the proof, if we look at triangle, we can say in triangle BEC. If we look at triangle BEC, we can see that D is the midpoint of a triangle, of side of a triangle, and it is given that DF is parallel to BE. So it is given that D is midpoint of BC. At the same time, it is given that DF is parallel to BE. Now we know that converse of midpoint theorem says that in a triangle, if a line is drawn from a midpoint, from the side of a midpoint of one side, and if it is parallel to the second side, then it bisects the third side also. So if you look at this triangle, this is the midpoint, and from the midpoint a line is going which is parallel to the other side. So according to midpoint theorem, this point, that is F, will be the midpoint of CE according to midpoint theorem, according to the converse of midpoint theorem. So what we can say, we can simply say that F is midpoint of CE. Reason is converse of midpoint theorem. Now if F is the midpoint, it means we can say that CF is equal to half of CE. That is very sure. If F is the midpoint of CE, it means this CF and FE will be equal, or we can say that CF is equal to half of CE. That is what it is written. But we know that CE is half of AC. What is the reason? Because E is the midpoint. It is given that BE is the median. If BE is the median, then E is the midpoint. If E is the midpoint, then EC and EA will be equal, or you can say AC is double of CE, or CE is half of AC. So in place of CE, we can write the value half of AC. So we are writing 1 upon 2 of AC. When you open the bracket, or simply when you multiply, it will be 1/4 of AC, and that is your proof. That is proof. Now we move on to the next question. Now question number 8. Question number 8 is in the adjoining figure. Figure is already given. So what do they say? In the figure you can see ABCD. It is given as a parallelogram. They say that ABCD is a parallelogram. E and F are the midpoints of AB and CD. So E and F are the midpoints of AB and CD. Now they say that AB and CD, the straight lines AF and BF meet at F, and DE and CE meet at E. Meet in the point G and H, and these two lines meet at G and F. First thing you have to prove that HEB, triangle HEB and triangle HCF are congruent. First point, you have to prove that these triangles are congruent. So when we prove the triangles, congruency in the triangles, we generally write those triangles which we are considering. So we'll write in triangle HEB and triangle HCF. What do we find? You can see that this angle H and this angle H are equal because they can be said as vertically opposite angles, and we know that vertically opposite angles are equal. Now, one more thing you can say, since ABCD is a parallelogram, this is only to make you understand. Since ABCD is a parallelogram, it means that AB is equal to CD, because we know that in a parallelogram opposite sides are parallel as well as equal. Now if AB and CD are equal, it's very obvious that it's half of AB will be equal to half of CD. Now half of AB is either AE or EB, so we can say EB, or we can write EB. Half of AB is AE or EB, but we need this side, so we are writing EB. And half of CD is DF and FC, so we are writing FC. So we got one thing, that FC and EB are equal. Now, and one more thing, you can see that this angle FCH is equal to BEH. Why? Because these are alternate interior angles. Two parallel lines pass and transversal passing. So this angle and this angle is known as alternate interior angles. So we can say, first point, we can say we are started with HEB. So we can say angle EHB is equal to angle CHF, and reason is vertically opposite angles. Second point, we can say that angle HEB is equal to angle HCF. Why? Because they are alternate interior angles. And third point, we can say that CF is equal to EB, and reason is that AB is equal to CD, since ABCD is a parallelogram. This has already been proved that ABCD is a parallelogram, so opposite sides parallel and equal, so AB and CD are equal. So their half will also be equal, and half of AB is EB and half of CD is CF. So that is what is written, CF and EB are equal. Now we can say by angle side congruency, these triangles are congruent. So we can say that triangle HEB is congruent to triangle HCF by angle side congruency rule. Hence this is proved. Now first part has been proved. Second part is GEHF. GEHF is a parallelogram. So what you can see that DC and AB are equal. I'm just explaining you. DC and AB are equal. Now half of DC and half of AB have to be equal. So half of DC can be DF and half of AC can be EB. So DF is equal to EB. At the same time, EB and DF are parallel also, since it is a parallelogram. So what we can say, DEBF is a parallelogram. It means this side and this side are parallel. Similarly, we will prove this side and this side parallel. So opposite sides parallel. Both the pair of opposite sides parallel, therefore it will be a parallelogram. Now I will move on to the solution part. Now the solution, we have to prove that GEHF is a parallelogram. So we can say that AB is parallel to CD and AB is equal to CD, since these are opposite sides of parallelogram. Which parallelogram? Okay, write it. ABCD. First of all, we will mention that this AB and CD are parallel and equal. Why they are parallel and equal? Because it has been given that ABCD is a parallelogram. So we know that in a parallelogram, opposite sides are parallel and equal. One pair of opposite sides are parallel and equal, or you can also say that both pairs of opposite sides are parallel. This is also a property of parallelogram. Now we know that AB and CD are parallel. AB and CD are parallel, and AB and CD are equal. So we can say half of AB will be half of CD. In place of AB by 2, we can write EB or BE. This is EB and this is DF is equal to DF. In place of half of CD, we are writing half of CD is DF. Now EB is equal to DF. At the same time, EB will be parallel to DF. Why? Because you can write the reason, since AB is parallel to CD. Now if AB and CD are parallel, these two lines are there parallel, so their some parts will also be parallel. Suppose I say this is XY line and this is PQ line. Suppose I say these two lines are equal, so I can say that these parts and these parts are parallel. AB, CD. I can say that AB is parallel to CD. So that is same concept we have used here. If AB and CD are parallel, then EB and DF are also parallel. This is point number 1. This is only proved. You can say that. So we can say that DEBF. So we can say that DEBF is a parallelogram because one pair of opposite sides parallel and equal. This is equal, at the same time parallel. One pair of opposite sides parallel and equal. So DEBF is a parallelogram. It means that GE and FH, it means that, or it implies that, you can say that therefore, we can say that therefore GE is parallel to FH, and this is my first equation. Now let's move on to the other point. What we can say, again AB and CD are parallel, using this only. AB and CD are parallel and AB is equal to CD. So we can say again AB, half of AB is equal to half of CD. So now this time half of AB can be considered as AE. So instead of AB upon 2, we can write AE, since AE is also half of AB, and instead of CD upon 2, we can write FC is equal to FC. Here we proved EB and DF, here we are proving AE is equal to FC. At the same time, you can say AE is parallel to FC. Therefore, since, why? Again the same reason, AB is parallel to CD. Now, if AE and FC are parallel and equal, it means that AECF is a parallelogram. So we can say over here AECF is a parallelogram. If it is a parallelogram, then we can say that AECF is a parallelogram. So we can say that EH and GF are parallel. It says that EH is parallel to GF. Now this is second equation. We have proved that GE, this side, GE and FH are parallel. At the same time, we have proved that GF and EH are parallel. Now, this is a quadrilateral. In this quadrilateral, we have proved that pair of opposite sides are parallel. Therefore, GEHF will be a parallelogram. So, no need to write all this. Just write from equation 1 and 2. We can say that GEHF is a parallelogram. That is proved. That is your solution. Now we move on to the next question. Now question number 9 is ABC is an isosceles triangle. So in this question the diagram is not given. So first of all we'll draw the diagram. We have made ABC as isosceles triangle in which AB is equal to AC is given. It is given that in which AB is equal to AC. Then they say that DEF are the midpoints of BC, AB and EC. So D is the midpoint of BC, E is the midpoint of AB and F is the midpoint of AC. Then they say AD is perpendicular to, we have to prove that AD. Now AD has come into the play. So we will draw a line from A to D like this, something like this. Now AD, we have to prove that AD is perpendicular to EF, means we have to prove that, let us say this point is M. So at point M, AD is perpendicular to EF at point M and is bisected by it, means AD is being bisected. It means we have to prove that M is the midpoint of EF. So what we can say, first of all, we know that E and F are the midpoints of AB and AC. If they are the midpoints, it means according to midpoint theorem, we can say that EF is parallel to BC. First of all, we can say that since E and F are midpoints of AB and AC, therefore EF is parallel to BC according to midpoint theorem. What we know about the theorem, that if in any triangle a line joining two midpoints a line which joins from the midpoints of two sides of a triangle is parallel to the third side. So we can say EF and BC are parallel. Number one, if they are parallel, we know that AB and AC are equal. If AB and AC are equal, it means angle B and angle C will be equal. And angle B corresponds to angle E. At the same time, angle C corresponds to angle C. So angle E and F will be equal. So what we can say angle B is equal to angle E. Why? Because they are corresponding angles, and at the same time angle C is equal to angle F. Again they are corresponding angles. Now when these two are corresponding angles, these sides and these sides are equal. So one thing we can take, I am drawing a separate diagram. This is triangle ABC. They say that AB and AC are equal. So it means this and this angle are equal. Now in between there is a line, that is the AD. Now this side and this side is equal. This and this is equal. And D is the midpoint. It means this side and this side is equal. So side angle side, side angle side. So we can say this triangle and this triangle are congruent. So first of all, I would have mentioned that triangle, we can say that triangle ABD is congruent to triangle ACD. By what reason? Side angle side, by SAS rule or by SAS rule. Now we have already proved that this triangle ABD and ACD are congruent. When these two triangles are congruent, then we can say that this angle and this angle, means angle BAD will be equal to angle CAD, or you can say implies that angle BAD is equal to angle CAD, reason CPCT, and I hope you remember what is CPCT. So we can say that angle BAD and CAD are equal. So here also we can say that angle BAD and angle CAD are equal. So if we consider triangle AEF, in this I have to prove that this angle and this angle is 90 degree. So what I can say, I'll write the two triangles that I'm considering. Considering this small triangle and this small triangle. So I'll write in triangle EAM and triangle FAM. What we can say? First point, we can say angle AEM is equal to angle AFM. Why we can say this? Because angle E is equal to angle B and angle F is equal to angle C. Angle F is equal to angle C, angle B is equal to angle E. And we have already proved, since AB is equal to AC, it implies that angle B is equal to angle C. If angle B and angle C are equal, in place of angle B we can say angle E, and in place of angle C we can say angle F. So angle C and angle B and C will be equal. Angle B and C are equal given. So we can say that angle E and F will be equal. So AEM is equal to AFM by this reason. By it is already proved above. No need to write so much, but proved above. But since I am explaining you, so I am trying to make everything clear. Now first point. Second point, we can say, you know that AB is equal to AC, it is given, and E is the midpoint of AB and F is the midpoint of AC. If AB is equal to AC, then half of AB will be equal to half of AC, and half of AB is AE and half of AC is AF. So this also can be written as, second point we are writing AE is equal to AF. Why? Since triangle ABC is isosceles given. Second point. Third point, we can say that angle EAM is equal to angle FAM. EAM is equal to FAM. Why? It has been proved here by CPCT. So you can say CPCT, already proved above, or even you can say proved. Now you can see angle, side angle, angle, side angle. So we can say that triangle EAM is congruent to triangle FAM. Reason is ASA rule. When these two triangles are equal, we can say, now when we see at this one, we have already proved that this was A, E, F, M. We have proved this angle and this angle equal, this angle and this angle equal, this side and this side equal. When the triangles have been proved congruent, when triangle EAM and FAM have been proved congruent, it means all the 6 elements of first triangle are equal to the corresponding 6 elements of second triangle. It means this angle and this angle will be equal. So we can say that angle AME is equal to angle AMF by CPCT. Since triangles are congruent, so all the elements of first triangle is equal to the corresponding elements of second triangle. So we can say this angle and this angle are equal. So that is what we have written, AME and AMF equal. But we know that EMF is a straight line or a straight angle, and we know that this makes 180 degree. But we can say that angle EMF is equal to 180. So in place of EMF we can write angle AME plus angle AMF, that is 180 degree. Now both of them are equal, so we can replace any one in place from any one. So we can say 2 times of angle AME is equal to 180 degree. Therefore angle AME is equal to 180 upon 2, that is 90 degree. So we have proved that this angle is 90 degree. If this is 90, then obviously this is 90. Now these two angles have been proved, and at the same time EM will be equal to MF, because we have already proved that these two triangles EAM and FAM are congruent. Or we can simply write that, we can write here as EM is equal to MF by CPCT. So both these things have been proved. First thing, that this AME is equal to 90 degree, or AM is perpendicular to EF. Second point, that AM is bisected by EF. So this and this is bisected by E and F. Okay. Now we have proved that AM bisects EF, but one thing is left, that is A is bisected by it. Means AD is bisected by AD is perpendicular to EF and AD is bisected by EF. It means we have to prove AM is equal to MD. That we'll prove now. First we'll rub it out, then we'll move. Now the second part is we have to prove that AD is bisected by it. By it means I'm writing it here, EF. AD is bisected by EF, or what I am writing, now one part has been proved, so I'm writing that AD is bisected by EF. We have to prove AD is bisected by EF. Means we have to prove that AM is equal to MD. This is what is required to prove. Now what we can see, F is the midpoint of AC, D is the midpoint of BC. So FC will be parallel to AE. First point, we can say FD is parallel to AB, and FD is equal to half of AB. Reason is again midpoint theorem. Second point, we can see that E is the midpoint and D is the midpoint, so ED will be parallel to AC and half of AC. Second point, I am writing ED is parallel to AC and ED is half of AC, and reason is same. Same means by midpoint theorem. Now when FD is equal to half of AB, then it means from this AB upon 2 means it can be written as AE also. Half of AB is AE because E is the midpoint, and half of AC can be written as AF also. So we can say that FD parallel AB and FD is equal to AE. At the same time, we can say that ED is parallel to AC and ED is equal to AF. This side and this side parallel, this side and this side parallel and equal. So we can say that from, let it be 1, let it be 2, we can say that AEDF is a parallelogram. Since these two sides are parallel and equal, these two sides are parallel and equal, so EDFA is a parallelogram. If EDFA is a parallelogram, then we know that AEDF is a parallelogram, or if this is a parallelogram, we know that in a parallelogram diagonals bisect each other. Diagonals bisect each other. Therefore AD is bisected by EF. Therefore, because diagonals of parallelogram bisect each other. So because of this reason, we can say that AD is bisected by EF. Basically, this is not a parallelogram, this is a rhombus, because AB and AC are equal. Half of AB is AF and half of AC is AE, and AF are equal. When this and this is equal and this is parallel, one pair of opposite sides parallel and equal, so obviously this is a parallelogram. But this side is equal to this side also, so it becomes a rhombus. And in a rhombus, the diagonals perpendicularly bisect each other. And here also we can say that these are 90 degrees, so they are perpendicularly bisecting. But we required only to prove that AD is bisected by EF, so that is what it is proved. So that is all for today. There are 2-3 questions more left that will be covered in the next class. Till then, keep watching and keep studying hard. Thank you.